I have the textbook's definition of a Taylor series over here on the side. Function into the derivative of the function, and also into a polynomial that keeps increasing in degree. So since this notation here, this is talking about the nth derivative. You keep on going into infinity, and eventually, if you go to infinity, you've got a function that's matching. You've got a series that's matching the function that you're talking about. So it's good to list the derivatives of the function. Cosine x is negative sine x, and then we got negative cosine. To see the pattern, but one more, fourth derivative. It's going to be back to sine of x, and it repeats itself every 4 derivatives, right? If you want to start working with the Taylor series formula, the first thing we're supposed to do is to do sine of the center point, pi over 2, and then that's multiplied to x minus our center. We just did this piece here, and then it's plus the second derivative at pi over 2. Then it's over 2 factorial. Then that's x minus pi over 2 squared. That's the second derivative. So now the third derivative, it's negative cosine. Actually, I think we're going to need to do one more because we're going to get a lot of zeros. Because pi over 2 means 90 degrees. Cosine is the x coordinates on the unit circle. This is 0, 1. We probably should go one more term. I'm kind of out of room here, but one more just because we're going to have so many zeros. Now, working on the fourth derivative, we're back to so there's a lot of terms here that are going to simplify. Okay, so I'm taking this whole thing and I'm going to start doing a lot of simplifying. First, sine pi over 2 is 1. So this whole thing is being multiplied by 0, so that's 0. And then we have negative sine pi over 2. This is sine pi over 2 negative. And then it's x minus pi over 2 squared all over 2 factorial. And then the term is 0. This is 1, so that's x minus pi over 2 to the 4th. So it's alternating. That's one thing we're getting out of this. 1 and then plus a negative. So this is like minus this term plus this term. And if you were to keep going, it'd be minus plus minus plus. Okay? It's going to be an alternating series. The next term is going to be a negative in there. So when we're trying to find the Taylor series, we're trying to write it in series form. Excuse me. Let's zoom in so I can have a little more whiteboard space. So it's a sum from n equals 0 to infinity. We're going to have an alternating term, a positive 1 when we plug in n equals 0. And then the terms that are going on here, this is an even number, so I'm going to write x minus pi over 2, and then we have an expression in math to make something even. It's just 2 times a variable, 2 times an integer, right? So 2 even as well. So that you could plug that into n equals 0, thing becomes 1, this is 1, that makes 1. If you plug in n equals 1, then you get x to the second power. The last thing we just need is to take care of this factorial. It's the same thing. That's always 2 factorial, 6 factorial, so we're going to do 2n for the denominator. That way, we always have even numbers coming out of the denominator. So that'd be 2, if you plug in n equals 1, that'd be 2 factorial. If you plug in n equals 2, that gives you 4 factorial, just like it's supposed to. So now we're done. So it's really about expanding the first few terms of the Taylor series, finding the Taylor series form like I've done down here.